Welcome, dear learner. We are discussing about the physical techniques for synthesis of a nanomaterial. In previous lecture, we discussed about the physical vapor deposition technique. In physical vapor deposition technique, the heat is used to evaporate the material, target material. And this vapor, so that it is converted into the vapor form, and the vapor is deposited on the substrate. Friends, in this lecture we have to see what is this sputtering technique. In a sputtering technique, the process is the same, only the here we use the inert gas, and the inert gas is an incident on the target material. Inert gas such as argon, which is an incident on the target material, so that the plasma is produced, or atom, or we can say that the molecules are produced, and these molecules are deposited on the substrate. So we have to see what is this sputtering technique. Sputtering technique, this method is used for thin film deposition, especially to obtain stoichiometric thin film. Stoichiometric thin film means there is a without changing the composition of a original material. The material is deposited on a substrate without changing its composition. Okay, then the sputtering is effective in producing non-porous compact film. So there is a very good adhesion between this material, target material and substrate, so that the film is non-porous. Target material may be some alloys. We can use a ceramic, or it's a compound. Then it is a very good technique to deposit multi-layer films for mirror, or a magnetic film for spintronics application. Spintronics means spin electronics. So we can consider the intrinsic spin and extrinsic spin, okay, of electrons. In this method, inert gas like argon is incident on a target at high energy. The voltage is applied between a target, that is cathode, and substrate, that is anode. A plasma is created by ionizing sputtering gas. When the argon gas is incident on the target material, then the plasma is produced, or atom molecules of a target materials are ejected into the gas form, or we can say that the plasma is produced due to bombardment of a sputtering gas. Ejected target material is deposited on a substrate. Now this is the diagram which shows the sputtering technique. Here, argon gas, which is inert gas, is an incident on a sputtering target, or a target material. Okay, so that photons, electrons, atom, ions, molecule, or simply plasma is produced. Now this plasma is deposited on a substrate, and there is a film growth is a from. We can use a glass substrate, or we can use a glass substrate is a conducting glass, okay, or we can use stainless steel as a substrate. Here uh, there is a anode and cathode, okay, and the high voltage is applied across anode and cathode. Anode and cathode, we can use the sputtering target as a cathode, and and the substrate as anode. This whole assembly is placed in an evacuated chamber. There is an evacuation is carried out, and the pressure inside this evacuated chamber is about a 10 to minus 3 torr. The target material sputtered yield is given by the equation y is equal to 3 alpha divided by 4 pi square 4 m1 m2 divided by m1 plus m2 into E1 upon EB, where alpha is the efficiency of a momentum transfer. When the argon gas is incident on the target material, photons, electrons, atoms, ions, molecules are emitted, and some momentum is a transfer from the argon gas to this atom or molecule, and alpha is the efficiency of that momentum transfer. M1 is a mass of a incident ion. Okay, M2 is a mass of a target atom. We can use a different target atom. Okay, M1 is a mass of a incident ion. E1 is the energy of a incident ion, which is less than 1 kilo electron volt, and EB is the binding energy of a target atom. Okay, here the energy of an incident ion is also depend on binding energy of a target atom. If a binding energy is large, then the energy of incident ion also large. So we required large energy to eject the atoms or molecules. Okay, so this is a diagram. Now, sputter yield for a different element with a same incident ion have same energy. This would lead one to think that from a target consisting of a two different element or more, the one having high sputtering yield should get incorporated in larger quantity than the other. However, high sputtering yield element get depleted fast, and the other element also make contribution. Thus, the stoichiometry is achieved in the deposited film. You can ask or question can be asked to you, why sputtering technique film have the thin film which produced by sputtering technique have high stoichiometry. Okay, sputter deposition can be carried out using direct current, that is DC sputtering, radio frequency sputtering, or magnetron sputtering. The deposition is carried out in a high vacuum or ultra high vacuum system equipped with electrodes, one of which is sputter target and other is substrate. Gas introduce facility is also available. The quality of vacuum ensure the purity of a film. Now we have to see what are the different advantages of this sputtering technique. The material having high melting point can be easily sputtered. Films by sputtering have better adhesion on the substrate than the evaporated film. So there is a very good adhesion, okay, of a material with the thin films. This method is used for thin film deposition, especially to obtain stoichiometric thin film. Sputtering is also effective to produce non-porous compact film. The target material may be some alloy, ceramic or compound, or we can make the thin films of alloy, ceramic or compound. These thin films are non-porous. It shows good stoichiometric thin films, and there is also better adhesion. It is a very good technique to deposit multi-layer films for mirror or magnetic film for spintronic application. So these are the advantages of a sputtering technique. Now disadvantages. The inert sputtering gas are built into the growing films as impurity. So due to this inert sputtering gas, some impurities are added in the thin film. This is the disadvantage of the sputtering technique. Thank you.